Excellent! Let's talk about eggs. Today, when we talk about eggs, we're going to be focusing on a couple different things. First, we're going to focus on their eggshells. Then we're going to go to the heart of the matter and discuss proteins. And in so doing, we're going to look at two very fundamental, easy, fun experiments. Ones that you're probably already doing without me asking you. Let's talk about eggshells. Eggshells consist of two things. They consist of calcium carbonate, and they consist of proteins. And we're going to have lots and lots of fun with proteins today in our lab. The first thing we want to do is we want to focus on the calcium carbonate. Calcium carbonate's a mineral, for lack of a better term. Actually, I shouldn't use mineral. That has very specific meaning in terms of geology. Mineral implies basically one element, and this is obviously a compound. Calcium carbonate's an ionic compound. And calcium carbonate's very fun. If you've ever reacted baking soda and vinegar, you've seen how carbonate reacts with an acid. When calcium carbonate is reacted with an acid, it forms water and carbon dioxide gas. If you've ever reacted baking soda and vinegar and seen a lot of bubbles form, that bubble is carbon dioxide gas. So one of the things you're going to be doing in today's experiment is you're going to be taking an egg, an uncooked egg at that, and you're going to be placing that egg in vinegar. Vinegar, scientifically, is known as acetic acid. And when you react acetic acid or vinegar with the calcium carbonate in an eggshell, what you get is calcium acetate dissolved in a solution, but we don't really care about that. What we do care is we care that we get carbon dioxide gas formed, and we also get some water formed. But that carbon dioxide gas is going to produce bubbles. Another very important part of this reaction, of the reaction of the uncooked egg with acetic acid, is the calcium carbonate in your egg cell is a solid. Once it's reacted with the vinegar, it's being dissolved into a solution. So your calcium carbonate goes from being a hard solid to a substance that's dissolved into solution. So not only are you producing a gas that you can observe in the form of bubbles, but you're also going from having a solid to having an aqueous solution. In other words, you're making part of your eggshell disappear. Now, this is going to take time. Matter of fact, let's get a new slide for it. Okay, so I've taken an egg and I've soaked it in vinegar overnight and I've removed the shell. One thing you'll notice about it is you'll notice that the egg is still egg-shaped, meaning there has to be something there holding it together. Not only that, but we can see it bounce. Let's bounce with it. Let's slide with it. I'm sorry. 90s rap. Forgive me. All right. Let's watch it bounce here. Slow motion effects. Oh, that's so good. Let's see it again. Let's see it again. Let's see it again. You can see that the egg's not only bouncing, but you can see it sort of quivers as it bounces. Not only that, but there's something still holding that egg together. So what is it that's holding that egg together? Underneath the eggshell rather. Wow. Okay. Definitely seeing why I'm not a comic book artist. You have what's known as a semi-permeable membrane. And this semi-permeable membrane keeps the egg together, and it allows for the passage of water molecules into and out of the egg. When we place, well, let's take a look at a semi-permeable membrane. Okay, I'm going to draw a little semi-permeable membrane here. And on one side, I have a solution that's nearly pure water. Bunch of water molecules. Over here, I have the inside of my egg. And I have protein and water molecules. However, the water molecules over here are in a more concentrated solution. They're having a lot of fun. They're partying with proteins. These water molecules over here, in the less concentrated solution, meaning it has less solvent particles, they're jealous. They want to party with the protein molecules too. So these water molecules will flow across the semi-permeable membrane through a process called osmosis. And the process of osmosis can be defined as the movement of solvent particles, because, you know, we're chemists, we can't just say water. Osmosis is the movement of solvent particles, water, across a semi-permeable membrane from areas of low concentration, in other words, pure water, to areas of high concentration. So if I have a bunch of salt on one side of a membrane, salt water on one side of a membrane, pure water on the other, particles of the pure water will move to the side with the salt until the concentrations of the two sides are as equal as possible. Water always flows from areas of low concentration to areas of high concentration, and this process is called osmosis. we can demonstrate that osmosis is occurring when we do our bouncy egg if, when we do our bouncy egg, we add some food coloring. If we add food coloring to our vinegar when we dissolve our eggshell, the food coloring should actually enter the egg and make the inside of the egg a different color. So when you make your bouncy egg, you're going to add some food coloring to the vinegar that you're using to dissolve the eggshell, and that will hopefully wind you up with a colored egg, colored on the inside instead of the outside, like a normal colored egg. So that's the first experiment you're going to be doing. Not only are you going to see this with food coloring, but let's see if I can get my movie back. Can I get my movie back? Come on. Here we go. It's kind of hard to tell in the video, but this egg is swollen. One of the reasons it's so bouncy is it's swollen. Why? Because a lot of the water molecules through the process of osmosis have entered your egg, going from areas of low concentration to areas of high concentration. That's going to make your egg swell. So your egg is going to be swollen compared to what you'd expect it to be. It's going to look a little bit bigger than when you put it in. That's right. Once you remove the shell, the egg you take out will actually be bigger. How cool is that? Very cool. Of course it is. It's chemistry. The second part of today's experiment focuses on the other component of an eggshell, and that's the proteins. In order to get those calcium carbonates to form that eggshell shape, they have to grow on a structure. The structure that makes up the eggshell is actually made of proteins. Now, eventually we'll get to proteins in lecture, but proteins are substances that are long chains of amino acids. And amino acids have a pretty general form. Amino acids all consist of a... My stylus is just not working for me today. Amino acids consists of a carboxyl group connected to a carbon that contains an R group that will be different for every amino acid to what's known as an amine group. And we'll go into functional groups and everything a great deal in lecture. What you need to know for now is a functional group My stylus is just terrible today. Is a repeated pattern of atoms. And these repeated patterns of atoms occur so often that as chemists we like to name them so we can easily talk about them and their properties. An amino acid, in addition, an amino acid has what are known as two functional groups. It has a carboxyl group, and an amine group. And it's this amine group that we're actually going to be focusing on. In terms of talking about the properties of proteins and the properties of eggshells. All right, so let's take a look at that amine group. You'll notice that amine group there is forming 3 bonds. It's got a bond formed to the carbon behind it, right there, and it has a bond formed to 2 hydrogens. So I've kind of blown up my amine group here. I'm showing where it's bonded to the carbon, and then I'm showing where it's bonded to those 2 hydrogens. So I've got it bonded to my carbon, and I've got it bonded to 2 hydrogens. When nitrogen is like this, it also has 2 lone electrons. These 2 lone electrons are available for bonding. Well, what does that have to do with the price of eggs? If you'll pardon the pun. Oh, you know I was going to make an egg joke sooner or later. I just managed to beat you to it. I'm sorry. I hope I didn't scramble things up there. All right, I'm sorry. I'll stop making jokes. Just remember, I'm trying here, and always look on the sunny side of things. All right. I'll be playing all week. So make sure you try the breakfast buffet. We've met acids before in lab. Remember, acids are anything that when dissolved in water give off a proton. And a proton is pure positive charge. What do you think happens when we place an eggshell in vinegar? In addition to the vinegar attacking the carbon dioxide, attacking the calcium carbonate, the vinegar or the acid in the vinegar is also really, really interested in these proteins. All these hydrogens that are given off by the acid, they find those lone electrons on the amine group very attractive. And they'll actually attack those lone electrons in the protein. That means you'll wind up with a nitrogen that has picked up an extra hydrogen, and it's developed a positive charge. We make use of that positive charge when we dye Easter eggs. All right, full disclosure. Notice that I am indeed using a slide from Chemical and Engineering News 2017, created by Andrew Bruning here. Give credit where credit's due. Chemical Engineering News puts out lots of these info pictures, and I just love them. Additionally, it's a great follow on Facebook. If you go to Facebook, you can find Compound of Interest. I believe they're also on Instagram. And once a day, they'll put out something like this, and they're always just fascinating. Keep you on your toes, keep you sharp. Well, what happens when you place an Easter egg in vinegar, and the reason you place that Easter egg in vinegar when you dye it is you have all these proteins in the eggshell developing a positive charge. And it turns out that the dyes we use to dye Easter eggs, guess what? They have a negative charge. So what happens is they're very attracted to the positive charge that you've given to your eggshell. That's why whenever you dye eggs, you always put them in vinegar. Matter of fact, we're going to prove how important the protonization of the eggshell is in the second part of our experiment. In the second part of our experiment, we're going to dye eggs. Notice I did not say we were dyeing Easter eggs. We're dyeing eggs, right? This last part of the lab, in the last part of this egg lab, what you're going to do you're going to test the strength of different household acids using egg dyes as an indicator. Remember, in order for the dye to stick to your egg, there has to be acids there to do protonation of the eggshell, make that eggshell develop a positive charge. The stronger the acid, the better job it's going to do of protonating the eggshell. And therefore, the more intense the color you should be able to observe. You're going to test 3 different household acids. You're going to test 3 household acids. You're going to test aspirin, vinegar, and orange juice. If you're allergic to orange juice, and you're saying that people are allergic to orange juice, yeah, I'm actually allergic to orange juice, believe it or not. But if you're allergic to orange juice, obviously don't use orange juice. Let me know if you have something you want to substitute there instead of orange juice. 3 households acids: aspirin, vinegar, and aspirin, vinegar, and orange juice. And then you're also going to use water with no food coloring as a control. What's a control? A control is something where you don't change a variable and you use it as a means of comparison for the other items in your experiment. So these are the 3 it is late. These are the 3 items you're going to test. The more intense the color, the stronger the acid. So by testing these 3, I'm going to ask you to make a judgment on which one of them is the strongest acid. And that's what you're going to do. You'll want to take pictures . At the end of the experiment, why don't you write down Egghead? Write down Egghead, played by Vincent Peale in the 1966 Batman TV series. Egghead.